Okay, well, thank you, Larry, and good afternoon. It's certainly a pleasure to be here, and you've had some interesting dialogue already that I've witnessed. It's always great to hear from Larry Burns. I learn something new from him every time I hear him. So I want to thank SAP for inviting me here today, and to talk about the automotive industry, but specifically to talk about Delphi. So after hearing the morning sessions, I'm more convinced than ever that we are in the midst of an exciting time in automotive history. And it's becoming even more clear as we drive fast and furiously into this even more exciting future. How far we go hinges on our ability to reliably move more data around vehicle systems and faster. Now, not only does that make for interesting work, for me personally, it feels like coming full circle, if you will. My first job out of college was putting microprocessors into engine control units. And when I found out that that's what I'd be doing at General Motors, I wasn't exactly thrilled about that. I wasn't sure about the technology at the time, and I had plans to do some real work. And back then, I thought that was radios and 8-track players. But it turns out that that job of putting the industry's first computer on cars, that job was one of the best I've ever had, and it put me on a very exciting path to where I am today. Now, right around the time I started that first job, a man named Gordon Moore started to get a lot of attention. Now, most of you here are likely well aware of Moore's Law. It says processing power doubles every 2 years, roughly, and that was his theory in 1965, and so far it's still holding up. Now, what I find most interesting about his prediction is when he first wrote the article explaining the concept, he also predicted that increasing processing power would bring innovations like personal computers, cell phones, and interestingly enough, self-driving cars. And so here we are, computers and cell phones have been around for quite some time, and finally, with our coast-to-coast fully automated drive earlier this year, we've proven the possibility of self-driving cars. So I think Mr. Moore would be proud. But the fact of the matter is, we have a long way to go before we really solve what is our biggest challenge or opportunity yet, and that's enabling global, safe, sustainable mobility. There are a confluence of factors driving that challenge. It includes a growing global population, it's a growing car park that Larry talked about earlier, it's a proliferation of technology into every aspect of our lives. And that gets back to just how exciting a time this is for automotive technology. Those dynamics are causing us to ask some pretty big questions. Will we see the day that an internal combustion engine produces zero emissions, for example? We wonder what the ceiling is for fuel efficiency. Is it 100 miles per gallon or more? We think about what it would be like if we eliminated all traffic fatalities. And what if in-vehicle connectivity became completely intuitive and seamless and 100% safe at the same time with no distraction? And we ask if this generation will be the one to witness fully autonomous driving become a reality. So as Larry Burns said earlier, revolution or evolution. And by the way, before Larry left, I reminded him that I am right-handed. Because he checks. The fact is, all of these scenarios are within reach, and the companies that can deliver the innovations to realize those visions will be the ones to win. It's that very reason that Delphi is so keenly focused on the megatrends of safe, green, and connected. Being able to understand these megatrends and being able to meet customer expectations in those areas is the key to realizing the full potential of this perfect storm of challenges and opportunities. But there's something else too. Solutions in the safe, green, and connected spaces all depend on the ability to reliably move data around the vehicle and even outside the vehicle at very high speeds. So consider that a car, which includes over 50 microprocessor-based computers and uses as much as 100 million lines of software code, is easily the most sophisticated piece of electronics that a person owns today. Yeah, compare it to an Android phone, for example. It uses 12 million lines of code. Or the 44 million lines of code that run Microsoft Office. Even Facebook, with 1 billion users, is at 61 million lines of code. And something as complex as an F-35 fighter jet, with all the avionics and weaponry and triple redundant systems, et cetera, it operates with a mere 24 million lines of code. So it's clear that the future of automotive technology is data-driven. And I'll come back to that in just a minute, but first let's look at each of the megatrends in a bit of detail, and I want to start with safety. So globally, every 30 seconds, someone dies in an accident, and that's about 1.3 million deaths per year on our roads. And as Larry said earlier, that is a tragedy. And on top of that, upwards of 20 million people are injured each year in car accidents. So with active safety, we can significantly reduce those numbers. In fact, with near-term active safety technology, we believe we can save thousands of lives per year in the United States alone. Now, I'm not talking about advanced levels of automation here. This is technology that's on the road today and will be available in just the next few years. So for example, I'm holding up a product we call RayCam here. You'll understand why in a minute. It's the first system to combine both a radar and camera into one package. It makes it the most compact radar camera device on the market. So BCG just came out with a study last week, and it noted that advanced driver assistance systems, or ADAS, technology can reduce traffic fatalities by 28%, saving lives and money. And importantly, ADAS technologies are a major building block for delivering an autonomous driving experience whenever that might occur. That same BCG study says that partially or fully automated vehicles could reduce accidents by up to 90%. And again, this isn't pie-in-the-sky ideology. This RayCam is launching right now on the Volvo XC90. It's in production. And most OEMs are looking for more ADAS technologies for near-term implementation. So technology is enabling even more safety, which is a great development. And perhaps even greater is the reality that OEMs, consumers, insurers, and other stakeholders are acknowledging that active safety features are worth the investment. Now, vehicle manufacturers are also depending heavily on the supplier community to help address the stricter emissions and fuel economy mandates around the world and the consumer demand for better fuel economy. We don't have our eyes on just meeting those requirements and consumer demands, but we're working to exceed them. Our recent investment in Tula articulates that philosophy well. Together with Tula, we've collaborated on a technology called dynamic skip fire. It uses software, not hardware alone, but software to control the number of cylinders that fire on every combustion cycle. And the result on an 8-cylinder engine is about 15 to 20% better fuel economy without any sacrifice to performance. Now, we've had mechanical cylinder deactivation for many years. We supply a lot of products into that ourselves. An 8-cylinder running on 4 cylinders, for example, or 6 cylinders running on 3, if you will. The beauty is with the dynamic skip fire technology is you can select and run on whatever number of cylinders would be required for that particular load for those particular conditions. And the beauty is that the technology prevents the noise and vibration issues that some drivers notice with a mechanical deactivation. And ultimately, when the driver presses the pedal, the engine responds to whatever the consumer is asking for at that time. So with software deactivation, it happens so fast, the driver never notices when the cylinders are turned off, but for sure they're going to notice it when they pull up to the gas pump. Another great Delphi solution to meeting emissions requirements is 48-volt hybrid technology. Now, the industry's looked at hybrid technology for some time, but it seems like we've reached a tipping point here. And Delphi today has a cost-effective 48-volt system that provides electric propulsion assist to the internal combustion engine on board. It delivers 70% of the benefit of a mild hybrid for roughly 30% of the cost. So this is a lever that the OEs are going to pull as they march towards that 54.5 mile per gallon requirement by 2025 in the United States. Now, these are just two examples of many leading-edge technologies that we're focused on to address environmental issues. Hybrid, electric, natural gas are all part of our green portfolio, and all are key to ensuring that we're not only part of the conversation, but we're leading the discussion about green solutions for tomorrow. Now, finally, there's connectivity. Now, Steve Schwenke from OnStar this morning did a great job talking about this space. More and more consumers are being connected 24 hours a day, 7 days a week, and they want that ability in the car. You want that ability in the car. You also want the features and functions in the car to keep pace with those on our smartphones and tablets, with our digital lifestyle, every place else that we are in our lives. Now, Delphi has a strong heritage in this regard, and going way back, when radio became the main means of communication and entertainment, people wanted to stay informed and entertained on the road, and we answered that desire in 1936 with the world's first car radio, in-dash. And we've continued to push the envelope in infotainment and entertainment ever since, if you will, including we've given the world the rear seat entertainment, the Bluetooth connectivity, internet connectivity, digital music streaming, and embedded telematics. We were certainly a partner to the OnStar creation talked about earlier today when we were part of General Motors back in the day. So today, the traditional idea of telematics and entertainment, infotainment, has expanded, and connectivity is something that touches nearly every part of the vehicle today. And as was mentioned last evening, the user experience and car connectivity has become the battleground for the millennial car buyers, if you will, with horsepower and styling becoming increasingly less important. Now, nothing speaks to where we think the future of the connected vehicle technology is headed louder than our partnerships. By working with companies like Apple or Google, NXP, Freescale, TomTom, Mobileye, and many more here, we ensure that our software code works with others as well. And we also look to collaborate at the highest levels to ensure we have the best of both worlds. That's automotive grade and technology. So for example, we work with NVIDIA for high-end microprocessor solutions, with AVL and Tula to enhance powertrain engine management systems, with QNX, provides an operating system that enables a range of infotainment features. With Quanergy, it gives us low-cost, solid-state LiDAR. And Mobileye delivers vision algorithms for Delphi's active safety systems. So the landscape is shifting for sure, and the dominant dynamics of this change further substantiates the business case for a focus on safe, green, and connected. But the real emergent sweet spot for Delphi is the convergence of all three megatrends, the safe, green, and connected convergence. And this is where automated driving comes in. Like I said earlier, Larry Burns did a nice job talking about this space, and I certainly support his mobility moonshot challenge, by the way. Automated driving does represent opportunity in the safe, green, and connected spaces together individually and collectively. The foundation for this, though, is going to be active safety. And we started this journey actually back in 1959. It was on a Cadillac Eldorado. We had cruise control there. You saw Larry mention it on his timeline. And since then, we've added other building blocks like radar, like vision, vehicle-to-vehicle communications, and now LiDAR. And that expands when you consider that enhancements that connected and green also will bring to the table. So it's been a journey getting to where we are, but we've got miles to go here for sure. We've got a real taste for that possibility of this convergence during our coast-to-coast, fully automated drive earlier this year. Before I get into the details on that, let's take a look at the highlight reel on this.
One of the most buzzed about showings at the Consumer Electronics Show was a preview of the driverless car. We can expect to see urban driverless technology like this hit the market in the next 10 years. For the PBS NewsHour in Las Vegas, I'm Steve Goldblum.
The idea for this trip came about after a very successful show in CES 2015 in January. So we started to think, what would benefit the technology, and also what would help us prove out that this car is capable of moving to market quickly. We decided that collecting 2.5 terabytes of data and being the first to go coast to coast in the United States with a self-driving car or an automated car would be pretty compelling. How does a car drive itself? An analogy that we like to make when you ask is think about how a human works. If you think about your eyes, your ears, and your nose as the sensors, the same thing happens with vision and radar and laser on the vehicle. The controller is kind of like your brain, and the smart logic and the software that runs on that is really the heart and soul of how the car drives itself.
So what our coast-to-coast drive did was big in terms of what we demonstrated, but it was really big in terms of what we learned. I had the chance to ride with the team from Philly up to New York City on the last leg of the journey, if you will, and I got to tell you, it was quite an experience. But that's just a short portion of the roughly 3,400-mile journey that the car traveled. So all in, our car traversed 15 states. It took 9 days. The car was faced with a lot of different weather conditions and obviously a lot of different traffic conditions, which is what we were after. But still, we managed to stay in fully automated mode about 99% of the time. So, in other words, of the 3,400 miles traveled, all but roughly 34 miles were driven fully automated, hands-off. But that also means that it drove the speed limit. And that generated some interesting gestures along the way, for sure. So I think this is the first coast-to-coast fully automated drive, but I'm very sure this is the first time a car's gone coast-to-coast at the speed limit. And I think the drivers of this car and the creators of this car deserve special recognition just for that. And we learned a lot from the test, this real-world driving experience. We learned that our car was, I'll say, overly cautious around semi-trucks and oversized loads, for example. It really biased over into the very opposite edge of the lane whenever it passed one or was passed by one. Now, of course, as a human driver, we all do that anyway, right? But it was interesting to see how that bias felt when a computer was calling the shots. In addition, we verified that radar technology works in all kinds of weather conditions. It performed flawlessly all the way through. And as you travel coast to coast, you see a lot of big metal bridges and structures over some of the major rivers in our nation. They tend to have low ceilings. There's lots of steel girders. It really is a radar engineer's nightmare, if you will. But the radar technology worked great, and I couldn't be more proud of the team for that. We also learned some things about vision systems, some minor difficulties with a low sun angle early in the morning, late at night, and inclement weather can cause some minor difficulties. But all in, the combination of these sensors was absolutely awesome. So we learned a lot, and we'll learn even more as we dissect the 3 terabytes of data that we collected. I think the video said 2.5, but by the time we got back, it was up to 3, and they're still going through it. That's a lot of data. But the goal here is not only to understand the technology better, but to optimize the technology that we have, to make our sensors better, make our vehicle control algorithms better, understand the trade-offs between a radar and a vision system, a LiDAR and a radar, vehicle-to-vehicle versus vision, so that we can more cost-effectively produce a sensor suite that ultimately may get used for a fully automated vehicle sometime down the road, but can provide active safety benefit today and tomorrow for the drivers of the world. So importantly, getting here is going to require more than just one technology, more than just a technology focused on the megatrends. The future of vehicle technology, no doubt, is going to require additional and more sophisticated electrical architectures, including robust physical connections as well as high-speed and very high-speed data transfer. And that brings me to my earlier point about a data-driven future. It is the connected architecture that will define this future driving experience, if you will. It will be the nervous system that's going to enable all this. We're moving to a state where nearly every system in the vehicle is networked. It's about allowing drivers and passengers to safely connect to their media. It's about allowing safety systems to talk to brake systems, that talk to powertrain systems. It's about reconfigurable displays and even reconfigurable ride and handling. And it's about vehicles being able to talk to the infrastructure and even to other vehicles on the road. It's about being able to make life and death decisions in a fraction of a second. And it's completely conceivable that not too far down the road, when we talk about the fastest vehicles, we won't be talking about miles per hour. We're going to be talking about connectivity and processing power. But before we make that leap, we need to address vehicle architecture. Every vehicle today requires a robust electrical architecture to provide the routing and interchange of complex data and provide the power, the diagnostics, and signal to enable vehicle features and functions that you're all very familiar with. So consider what happens when you start your car. In just the first 2 seconds after you turn the key or push the start button, over 100,000 pieces of data are exchanged around the entire vehicle architecture. Over 100 diagnostics are pulsed just in that first 2 seconds. So right now, digital data is distributed at 65 megabits per second, roughly on roughly 300 diagnostic parameters around the vehicle. But soon that's going to increase dramatically to 1.5 gigabits per second, and it's going to be focused on about 1,000 or slightly over that diagnostic parameters. So if that sounds complex, it is. And while we're getting the job done today, we know that the current approach of adding ECUs to solve additional electronics requirements is simply not sustainable. It's costly, it crowds the network, we all know it slows down the movement of data. It's something you don't want in a system that's making life or death decisions. So we're reaching the limit on what a car can do with existing architectures. The degree to which cars won't crash, won't pollute, and won't contribute to congestion really hinges on addressing architecture and data speed. But Delphi's way ahead in this thinking, and we've been working on this nervous system of the future for some time. So it isn't just about wiring, it's a holistic approach. It's a new brain, new sensors, and a new way for the car to see, think, and react. It's a whole new architecture that can reduce the number of disparate controllers, sometimes as many as 100 on a car, by using uber brains, or something we call multi-domain controllers. So our new multi-domain controller enables each of the sensor controllers to maintain a basic operation, simplifies the architecture, but it provides a maximum computing power to enable fast, high-capacity active safety systems. Now, Audi is the early adopter in this architecture shift and will launch the multi-domain controller that you see pictured here for 2017 model year, and that's just around the corner. With the launch, this will become the most sophisticated piece of computational power ever on a car, and for the first time, future-proofs the architecture. Now, earlier I said that the shift must come, and with this, it's safe to say that this shift is already underway. Importantly, these multi-domain controllers can be future-proof. They allow enough bandwidth and headroom for car companies to imagine features years after hitting the market. And with some secure over-the-air upgrades, you get flexibility on par that you're used to with consumer electronics, and I'll say specifically your smartphone. So I'm talking future, but this is attainable. We're already doing over-the-air updates on our systems with a high degree of confidence today. With the right architecture, we will reach this milestone of making this ubiquitous. So imagine the possibilities. A software issue can be solved with the push of a button. How happy would you be as a consumer if you could fix problems over the air versus taking your car into the dealership for a repair or an upgrade, for example? How much money could you save from an OEM perspective, looking at it from their seat? The benefits here, the potential is massive. Now you take that thinking a little farther, and what opportunities could there be if you could offer different features and functions post-sale? If you could offer a new cockpit experience every year, just like we're all used to on our smartphones. Yeah, I think it's safe to say we're living in a very, very exciting time in the automotive world. Technology is pushing the limits, and we're making automotive great well beyond driving dynamics. So a lot of people ask me what I think about companies like Apple and Google and Uber getting into the car business. I can't really predict what the fruits of their efforts will be just yet. I was listening very closely to hear what Larry had to say about Google because he's been working with them for a while. But this I know, look, they're looking at the vehicle from a whole new perspective. They aren't constrained by traditional issues, and that has benefits, and it can drive progress at a very fast pace. No doubt it has the opportunity, and I think it will be disruptive. But they can't totally ignore automotive-grade expectations either. And I know for sure, you be the judge of this. You were not going to accept a software freeze or the blue screen of death while the vehicle's calculating what to do in a potential crash scenario, right? And launching a feature that only works 50, 70% of the time like Siri, I don't think that'll pass muster as well in an automotive environment. So there you are with the confluence of trends and capabilities and expectations. But regardless, today's competitive landscape forces us all to look at things in a completely new way. And like I said, that makes for exciting times. So I'll finish here. Safe, sustainable mobility is the future. Safe, green, and connected is Delphi's future. That's the way we've looked at it for the past several years, and that's the way we're looking at it going forward. Our ability to provide solutions as these three areas converge, along with our unmatched systems integration capability, is what we believe will drive our success. So the bottom line is Delphi made a conscious decision to focus our portfolio and become the very best at delivering highly innovative solutions to solve our customers' biggest challenges, and it's proven to be the right one so far. Today we're working on vehicle solutions that will enable 50% fewer emissions, 100% better fuel economy, 50% fewer accidents, and 1,000%, maybe 10,000% more connectivity, all by the time we reach the year 2025. That's what drives us. Thank you.
Are there any questions for Jeff? We have a little bit of time. And we have a microphone. Anyone's hand up? Yes, here we go in the front, or close to the front.
That 99% was phenomenal for that trip. Just curious, the 1% for the 34 miles that it wasn't fully automated, what were some of the things that caused that?
Yeah, we get asked that a lot. I actually experienced a couple of those myself. Usually it was an abundance of caution. So we were in a construction zone where had orange cones up that was in a weird zigzag pattern or something we weren't sure the vehicle would track. So rather than take a chance and see, we went into manual mode and just out of an abundance of caution. Another great example, the one thing about automated vehicles, fully automated, is they're very polite, right? So 3-lane highway, Philadelphia to New York, the cops got somebody pulled over, you see the light, you got to move out of that lane, right? So everybody moves out, but the lane beside you is full, right? But you still got to get over. So our car will put on the turn signal and wait for a safe gap to pull over, but if there's never a safe gap, we're going to get arrested. So out of an abundance of caution, went into manual there. You or I would show them a bumper and we'd get over, but the car's too polite to do that. So that was basically simple things like that. It was not we really didn't have a malfunction the whole time. It was just out of an abundance of caution. But 99% was way better than we thought we would do. We were thrilled with that. Yes.
Here it comes.
Jeff, I was just wondering if what type of product liability scenarios that you're seeing with driverless cars, if what kind of activity has Delphi done to investigate that and see where they stand legally in some of those collision issues?
Yeah, that's going to be one of the big questions that will enable or slow down fully automated driving, right? Is what's the legal framework and what's the regulatory environment? Neither of which we have yet. I don't think it'll be technology that paces the introduction here. I think it'll be what you just described, the legal framework, the regulatory environment, and then how much consumers are willing to pay. Or can you, as Larry said, can you take content off to make room for this, and will consumers be happy with that? Legally, the way we typically think about our products is if it'll operate to design and we manufacture it perfectly, then the liability goes with the car manufacturer. But I can tell you, this is a brave new world, and nobody's got this figured out. Everybody is worried about that, whether you're the Tier 1 or the Tier 2 or the OE or NHTSA, everybody's trying to get that nailed down. This is a place where the government could step in and facilitate this in a fast way if they wanted to. They could clear out these hurdles, but it remains to be seen how quick that'll happen. Yes?
So just how hard was it to let go of the wheel?
The first time it's tough. And I've been in a lot of vehicles. I've been in the Google vehicles several times, a couple times with Larry, as a matter of fact. It's in about 5 minutes, though, you get very comfortable. It doesn't take long, and I've not seen any exceptions to that, even from the nervous Nellies or the really the techno geeks that are really seeing beyond what's going on. But the first couple of times the car makes an adjustment, you're like, okay, is this happening right? And you see it's happening very similar to the way you would do it, and you get very comfortable that all's well. The vehicle algorithms may not be exactly like you do it, but they're close enough that you get peaceful. I mean, you really do, quickly.
Any other questions?
One back here.
Jeff, what are the innovation cycle times that you're expecting from your team these days, from light bulb idea to proof of concept or go to market?
Yeah, this is where we run into the convergence of Silicon Valley or tech clock speed and automotive clock speed, right? Two completely different clock speeds that are getting closer and closer together. I can tell you, we did that car, we actually built 4 of those cars because we knew we'd have to have one on every continent. We did 4 of those cars. There's 20 sensors on each of those cars. You wouldn't do that on a production vehicle, but we put it on there to take data. They were styled in. The team did a beautiful job of that. And you could still put your luggage in the trunk, right? It wasn't full of laptops and power supplies like most of our prior cars had been. But they got all that done in less than a year, right? Less than a year. But they did it in our Silicon Valley office. I'd like to think we could do that in Auburn Hills, or we could do that in Wuppertal or Luxembourg or Shanghai. But it really is that clock speed of Silicon Valley that we're trying to bring into the automotive space and accelerate what has typically been a 4-year cycle. But it has to be automotive grade, right? I mean, that's the challenge of moving from the tech sector into automotive. The tech sector looks at automotive and says, hey, that car stuff's easy. I'm doing the hard part. And the car companies look at the valley and say, you have no idea how hard the car is to do and live for 10 years. That tech stuff, that software, that's easy. And the real answer is somewhere in between, right? And that's what we try to do as a company, is try to be that bridge that accelerates the clock speed, but brings the technology in, but bring it in at automotive grade. Does that make sense?
How this car handle the difficult decisions over the road? For example, if someone's go in the middle, how the car defines if it need to brakes or it's too high a speed to brake because there is another car behind?
It's all part of the vehicle control algorithms, the thing that takes the place of the brain of the driver, if you will. So it's constantly evaluating the scenarios around, and then it's constantly plotting multiple paths forward. So nothing has to be calculated if something happens. It's already been pre-calculated, and you can go immediately to action. Literally in nanoseconds, you go immediately to action because it's been thinking about the surrounding environment. It's been thinking, is that car going to cut in? Is that car panic? What happens if it panic stops in front of me? What happened if this car's following me too close and I can see you can't see, it's on a cell phone, and it may not stop in time. Is the lane beside me clear? Is the berm clear? It's calculating all those potential outcomes and then takes the best possible one based on the algorithms that are installed. Now, we've already improved our algorithms a dozen times just based on this drive. So as we get more and more real-world experience, we're continuing to upgrade our algorithms with all the different permutations and combinations that you see. Ultimately, that becomes the challenge, right, of can it do it as well or better than you? I would offer today it's already better than almost every driver on the road. And one of the main reasons is it never gets distracted. It's not perfect. I don't know if it'll ever be perfect, right? But it never gets distracted. And distraction and human error are 90% of the reasons that we have accidents on the road today. That's where the technology will help. Whether we ever take the driver out of the seat, I think that remains to be seen, and at some time down the road, but you can get at that distraction factor, that 90% of human error, you can get at that today with the technology that's there today. That's what Larry was talking about with the mobility moonshot, and I support that 100%. I mean, it's good business, selfishly, but it's great. It'll be a great step forward for society. And then you can decide if you want to let the car drive or not, right? That'll be up to you, but you can get a big jump, a big increment of improvement in safety with the technology that's there today.
What type of experience you had it between the highways and the cities? I mean, cities definitely a different ball ground, so I just want to see what kind of experience you have it.
Yeah, it's definitely urban versus highway is two different animals for sure. We started last year at the Consumer Electronics Show, actually this past January, and we did urban demos for anybody that wanted one back then. We had 2 cars running an urban route. And in the crazy traffic of Las Vegas, you can just imagine the kind of things that we ran into. We actually had a couple of overserved patrons on the curb that fell off the curb, flat down, face down, right in front of our car when we were out for a drive with Good Housekeeping. So you hold your breath, right? You think, okay, to the earlier question, is it what's going to happen here? It already calculated multiple paths, went out to the lane beside and knew it was clear, stopped, would have stopped in time, but stopped in the lane next to it. So absolutely no concern for the people that were on the street, other than the fact that we're laying in the middle of the street in Las Vegas traffic. So, but it is a different challenge. Low speed, high permutations and combinations of different things that can go wrong. Traffic lights, a lot of traffic lights, some four-way stops. That again, that polite thing at four-way stops can be a factor. Much different than when you're at highway speeds and things are happening literally, a mile a minute kind of decision making. But all in, you can handle either one, but you have to have the algorithms experience and be prepared for all the permutations and combinations that you're going to be there. And we're still learning, right? As Google's learning. I don't think anybody has more data than Google at this point on the road, to Larry's point earlier, but we're all learning and we're taking that information back and improving our algorithms. Anything else?
Sorry. Thank you. Picking up on the last couple of examples you gave, I'm recently very interested in the technology, but also the ethical decision-making process. Yep. So taking your scenario, the car decides it's better to switch lane to avoid being rear-ended, yet there's a pedestrian on the same lane, and the car behind me, not being able to see it, may hit the pedestrian. So what is both the technical and the ethical response or attitude towards those kind of problems?
Well, again, a great question, and I don't have the final answer on this. This will be part of the one of the gating items to letting a computer control your vehicle. We've gone through that already with ABS and with stability control. If you think about it, we've gone through it with cruise control. But the ethical decisions in those cases aren't near as far-reaching as they could be in this case. So I think that's ground that still needs to be plowed. I think that gets back, particularly in the United States, to a legal framework that would put some definition around that and get everybody on a level playing field there. Our algorithms are capable of making multiple decisions, no question about it, multiple paths forward. And what you're asking is, do you calculate which is the least cost or the least disruptive path forward for me or for the environment or whatever? For society, yeah. Yes. Yeah, that remains to be seen. And I think in a case like this, it helps if the government comes in and gives a level playing field for everybody, but I don't see any danger of that happening here for a while. Again, I think that's going to be one of the roadblocks to ever taking the driver out of the seat. I don't have a problem if a car decides to stop before it hits something. There's no ethical dilemma there at all. But when if you're starting to make lane maneuvers and those kinds of things, you could run into that.
Thank you. When do you expect the development cycle for the completely driverless car?
For a completely driverless, so take the driver out of the seat? Look, I think we're 10 years away. I think we're 10 years away from a mass market offering. I know there's a lot of noise, and Larry talked about the people that have made different prognostications here. I think there'll be a lot of automation added to vehicles over the next several years, so you'll have use cases of automated. Hell, there's 5 cars today that you can ride on the highway at highway speed, set the cruise control, take your hands off the wheel, take your foot off the pedal, and it'll do its thing and keep you in your lane and keep you from hitting anything. You can drive for an hour that way on the highway already today. So you'll have more and more use cases where technology will provide an assist. Fully automated, I'm in the 10-year and beyond camp. Again, for some of the reasons we've talked about, legal framework, the regulatory environment, and how much will consumers pay.